Hi, beautiful people. So I'm making this to hopefully clear up a lot of the misinformation on the internet. A lot of the questions that we get in our Zoom meetings on my Patreon. A lot of things that you come to me and say, yeah, but this person seems to know a lot and they say this, or traditional use says this, and they seem to know what they're talking about. I want to give you some really basic information about the conversion science and how it works so that you can answer your own questions, hopefully. So in the basic chemistry, well, the most basic chemistry, the very first class, one of the very first things that you learn is what is needed for a chemical reaction. And most chemical reactions need heat to be able to push the reaction, and they need time. And then they need an aqueous solution to work in, or a fluid of some other kind of solution to work in. So you can have oil-based chemistry and you can have alcohols, but for what we are discussing, we're talking about water. We do discuss alcohols and we do discuss oils in some of the higher level stuff and other methods of use. But for this video, let's just talk about these basic components. You need the actives, you need heat, and you need some kind of a fluid medium. Yes, there is photoconversion, and this mushroom engages in it, but it's still in a fluid medium because it's still using the fluid that's in the mushroom itself while it's still in the ground interacting with the sun. Subject for another whole video. There are exceptions, but they are rare exceptions and they are oddities and not for common chemistry, basic chemistry. Knowing that these are the basic things needed for a chemical reaction, then let's talk about the myth that's out there that if you dry a cap, it is fully converted. So when you put a mushroom cap that's full of water and then you put it in heat, this is the perfect situation for a chemical reaction to take place. And so when you first start it, then you're going to immediately start getting some conversion, right? Well, what about when you're letting it air dry? You've got the fluid medium, but you don't have the heat. You're not going to drive a chemical reaction. That right there should tell you, even drying at room temperature, you're not going to get the conversion. Without the heat, just drying it in open air, you might convert about 10% of it. But when you put it in a dehydrator and you bump the heat up just a little bit, you're going to get a little bit more conversion, but the best conversion happens over 72 degrees Celsius. That is when you drive the fastest amount of conversion in the shortest amount of time. That seems to be that breaking point. Again, if you understand basic chemistry, you understand there's a point when you talk about reactions that are driven by heat. They move very, very slowly until this tipping point where all of a sudden the chemical reaction takes off. For this particular decarboxylation reaction inside the mushroom tissue, that is 72 degrees Celsius, about 165 Fahrenheit. When that happens, you take off on this chemical reaction, this decarboxylation reaction. However, here's the problem. You're also losing water rapidly, because it's not in a pot on a stove with a lid. It's a mushroom and it's dehydrating. That's the whole point. You want it to dehydrate. So it's losing water rapidly. So while you've got this chemical reaction speeding up because of the heat, you've got the amount of water going down, and at some point these two things will cross. I don't know how to do that. These two things will cross, and where they cross, that's where the chemical reaction turns around and slows down again. And you've got less and less water rapidly. When you dry at heat in a dehydrator, under the best possible conditions, the most you're going to get is about a 30% conversion. If you still don't believe me, then you can look at all of the studies that are using the actual mushroom and not lab created, ordered from a lab in the mail to study ibotenic acid or muscimol. You got to pay attention to your studies and what you're reading. What are they using? If they're using the actual mushroom and they're working with the actual mushroom and they need a control, the control is what you use to see what reactions and changes happen with the things you're testing, when you don't do anything to it, so you establish a baseline. Then the things that you're testing, you do whatever it is that you're testing. Whenever we do any kind of research on this mushroom, and we work on the cap, the actual mushroom cap, and they have to use it dried, but they don't want to mess with the ibotenic acid and muscimol in it, because that's what they're going to be studying, they dry it below 72 degrees Celsius so that they cause as little conversion as possible. That will be the control. If you don't believe me, go look at the studies. Why are they doing that? Because that's the basic chemistry of any situation. Any plant, any mushroom that's got any active ingredients in it that you want to dry, that you want to study, that you want to convert, that you want to work with, that you want to extract, every one of them has a heat where you are going to cause conversions from one important substance in there to another, where you're going to kill the actives, where you're going to render them inactive, or where you won't do any harm to them. This is for every plant and fungi that's got some kind of medicine in it that you want to work with. I'm giving you the science for this particular one. So if you order them in the mail from just about anybody, unless it specifically states they're dried over that temperature, they're just consider it a raw mushroom with no conversion. And there are reasons that you don't want any conversion. And I have a video that used to be called Different Conversions for Different Purposes. It's now called Using Ibotenic Acid and Muscimol. And that video, you need to watch it. It's in the conversion playlist about why you do want to use ibotenic acid, what people are using it for. We talk about it in our Zoom meetings on Patreon. If you think it's a neurotoxin, I have videos specifically about ibotenic acid science and why it is not a neurotoxin. Please watch those videos. And then there are some of you who are saying that you can take them dried and put lemon juice on them and reconstitute them and fully convert them. It sounds good in theory, but the problem is when you dry this mushroom, you start cracking the cell walls so that when you reconstitute them, they're going to turn into a blobby mass. And yes, some of that will get converted, but some of it has been already destroyed. And we need to get some science on that and some measurements on it. And then if you want to talk about re-drying it, once you've dehydrated it, added acid, this tissue, even though it's got chitin walls that are strong, once they break, we're talking about a very fragile molecule. And the destruction of that molecule, while it's got a higher heat, it can tolerate high heat, as far as that physical changes can destroy it. So there's no science on it. So people who tell you you can do that and you're going to do whatever, they don't know, because there's no science on that. We don't know what that does. I'm going by the chemistry, and I would think that if you didn't get it dried at heat, if you put lemon juice on it, based on what you're losing and based on the damage and then based on the conversion, that when you do that, you might convert another 10, maybe 15%. But you're also losing a lot of actives in that process by drying it again. So that's problematic. And then people who do the 3-hour boil, that's a bad method. I want to talk about that. And that is some basic chemistry. I have a video on the 3-hour boil and the basic chemistry in that. But along with the basic chemistry of you need a fluid, you need heat, and you need time, is that too much heat will kill it. Not enough heat won't cause the reaction. You need a fluid. Too much fluid, and you're not going to have enough of the reactants interacting with each other, and you won't get much of a reaction. Too little fluid, and you can't drive the full reaction. Time, not enough time, you won't finish the reaction. Too much time with this heat, and you start degrading your actives. So there's these sweet spots for everything. This is the study of chemistry. This is what you learn in chemistry, is anytime you go into a new chemical reaction, you want to know the heat, the fluid, and the time. How much, what temperature, how long. This is basic chemistry. So jump in, find all those videos. They're all organized by playlist. I love you, beautiful people. I hope this helps. Bye.